Hello, Matthews Gatos here. Welcome to Chapter 4, Trigonometry in the Unit Circle. This is the beginning of two chapters covering Trig 1. So in this lesson, section 4.1, we're going to do a two-part lesson. One part will cover angles and angle measurements, and the second part will cover arc length. So let's talk about angles. The most common unit for measuring angles is degrees and radians. So we've dealt primarily in degrees. So we're going to look in this lesson what a radian is. So if you think back to what you know about circles, I know that all the way around a circle is 360 degrees. I also know that all the way around the circle is circumference, found by doing pi times diameter, or 2 pi r, because 2 radii is the same as 1 diameter. So sliding these back together, you can see that means the same thing. All the way around the circle is 360 degrees, or 2 pi r. So I end up with this relationship that 2 pi r is the same as 360. Now in this trig unit that we're talking about, we're going to be dealing with a special circle called a unit circle. And a unit circle is just a circle that has a radius of 1 unit. So it's called a unit circle because the radius is 1 unit. So since I just discovered that 2 pi r is the same as 360 degrees and the radius is 1 unit, I know that 2 pi times a radius of 1 is just going to be 2 pi equal to 360. So I'm going to use this relationship to come up with some other relationships. So I know that 2 pi equals 360. What that means is that one full turn of the circle, all the way around the circle, is 2 pi radians, or 360 degrees. So if I know one full turn is 2 pi, I know that a half turn, which is going to be 2 pi divided by 2, because one full turn to half turn you divide by 2, is going to be pi radians, or 360 divided by 2 is 180 degrees. So now I know another relationship, that pi radians is the same as 180 degrees. Now I can also use this to say that if one full turn is 2 pi, well then to go down to a quarter, that's just dividing by 4. So 2 pi divided by 4 in lowest terms will be pi over 2. So 2 pi over 4, in lowest terms, pi over 2. So similarly for the circle, in degrees, 360 divided by 4 is going to be 90 degrees. And I can just keep going. So one full turn is 2 pi, so 1/8 of a turn will be 2 pi divided by 8, or in lowest terms, that would be pi over 4. 360 divided by 8 would give me 45. I can also build it up to be greater than one turn. So if one full turn is 2 pi, 2 full turns would be double that, which is 4 pi, or 720 degrees. I could just keep going on with this relationship. So from that one relationship of 2 pi equals 360, I have several other relations that follow. But that still doesn't really tell me what a radian is. So let's look at the definition. The formal definition of a radian is this. A radian is the measure of a central angle, so the angle in the middle there, where the arc length, that's this curved piece here, is the same as the radius. So you have 2 radii here, and you're cutting the circle so that the arc is also the same length. Like if I were to take that arc and flatten it out, it would have the same length as a radius. It's almost like I have an equilateral triangle there. So if we almost have an equilateral triangle, and I know that all the angles of an equilateral triangle are 60, does that mean that a radian is about 60 degrees? Well, that's a really good estimate. So 1 radian about 60 degrees, but I think we can get a little bit more precise than that. So we talked about the fact that 2 pi radians were 360, and the first relationship we saw was that pi radians equals 180 degrees. So if I want to know how much just 1 radian is, so I want to know how much 1 radian is, So 1 radian equals what? I could just take my pi radians and divide it by pi. And to be fair, I do that to both sides. So pi divided by pi is 1. So 1 radian is going to equal to 180 degrees over pi. So let's put that into our calculator and see exactly what that is. So plugging it into my calculator, I can see this is really close to 60 degrees. So that 60-degree estimate was really good, but this is a little bit more precise. So 1 radian is going to be about 57 degrees approximately. So again, a radian is where I have the radius, and this arc length along here, the curved part, also measures the radius. So when I talk about a radian, I'm talking about 57 degrees. Okay, we're going to need in this chapter to convert between degrees and radians back and forward. So I'm going to go to that relationship that I had, that pi radians is the same as 180 degrees, or 180 degrees is the same as pi radians. So if I want to convert degrees to radians, I want to come up with a multiplication factor. So if I were to divide both sides by 180, 180 divided by 180, I'm left with 1 degree is pi over 180 degrees radians. So that's my multiplication factor. My multiplication factor for every degree is a pi over 180. So if I want to go from degrees to radians, I multiply the degree by this multiplication factor of pi over 180. This is how I remember it. My tip is if I'm converting to radians, the pi goes on top because pi is a radian. So I'm going to use that multiplication factor to convert some examples here into from degrees to radians. So for example here, I have 210 degrees. So what I want to do is I want to do 210 degrees and I want to multiply it by pi over 180. That's my multiplication factor. But if I want exact radians, pi is an irrational number and it's not going to give me a nice fraction. Exact radians means I want it as a fraction. Let me show you what I mean. If I in my calculator do 210 degrees times pi over 180, I want to show you what I'm going to end up getting. Okay, so I'm going to do 210 degrees multiplied by pi over 180, which is my multiplication factor. So multiply it by pi over 180. So when I'm doing this, I'm going to get a decimal, and that's not an exact value. So then if we tried to put it into a fraction, math, fraction, enter, it's not going to work. And the reason it's not going to work is because pi is an irrational number. So we got to come up with a better way of doing this. So my tip to you when you're converting degrees to radians is to take pi out and put pi back. So what I'm going to do on my calculator, instead of 210 times pi over 180, I will do 210 times 1 over 180 to get my fraction in lowest terms. So if I take pi out, in the final answer, I put pi back. So I see that that would be 7 pi over 6. So as an exact radian, it would be 7 pi over 6. If I wanted it to the nearest hundredth, well, that was the number that I got on my calculator before. There it is, 3.66519, etc. So if I wanted it to the nearest hundredth, I would just say 3.67 radians. Okay, let's practice that with the other one. So negative 300 degrees. I'm going to follow this tip. I'm going to take pi out and put pi back just to come up with my exact value. So negative 300 multiplied by, well, my multiplication factor to go from degrees to radians. 2 radians means pi goes on top. So I'm going to take pi out and put pi back. So taking pi out and putting it back, I'm going to end up with negative 5 pi over 3. That's the exact value. And then to the nearest hundredth, it would be negative 5.24. Okay, so I want to look at going the other way around. So going from radians to degrees. So since I'm going from radians to degrees, see I'm starting with radians. Pi radians is the same as 180 degrees. So I want to figure out what 1 radian is. So I'm just going to divide both sides by pi, because then that's gone. And I'm left with 1 radian is 180 over pi. So therefore, the multiplication factor to convert radians to degrees, 180 over pi. So to go from radians to degrees, I'm going to multiply my radians by 180 over pi. So again, the way that I remember that is if I'm converting 2 degrees, the degrees go on top of the fraction. So let's try some of those. Okay, so I want to convert radians to degrees. So I'm going to take my radians and I want to go 2 degrees. So I'm going to put the 180 on top. Now I can put it into my calculator exactly like that, and you can see I get 225 degrees, or I can see that the pi divided by pi cancels, and I can just do 5 times 180 divided by 4. I would get the same answer either way. Okay, so to convert 6.35 radians to degrees, again, I take my radians since I want to go 2 degrees. I put my degrees on top, so my multiplication factor is 180 degrees over pi. So I just put that into my calculator, and I'm going to get that it is about 364 degrees. So just round it. Okay, so again, to convert from radians to degrees, the degrees go on top for the multiplication factor. So in this part here, I just want to review a little bit of some of the things that we did in 20-1 because they're going to come back into a play again. I won't spend a lot of time on here because this is just a review. I want to review that positive angles are measured counterclockwise. So you can see positive angles measured counterclockwise, negative angles are measured clockwise. Okay. Each of my quadrants is split into 4 sections, so I have from 90 degrees in each one of the sections. So I go from 0 to 90 to 180 to 270 back to 360. Now with the addition of radians, I'm going from 0 to half of a pi, a full pi, 1.5 pi, and back to 2 pi. Conversely, I can do that negative as well, and I have the negative quadrants measured as well. So same thing as 20-1, we're just throwing the radians into the mix. I want to review also how do I find a reference angle. So finding a reference angle, again, I denote that by theta with a subscript r for reference angle. A reference angle is a positive acute angle. Acute meaning between 0 and 90, or in radians from 0 to pi over 2. So really that's an angle made between the terminal arm and the x-axis. That could be the positive x-axis or the negative x-axis. So to review what we did last year in 20-1, in quadrant 1, theta is its own reference angle. In quadrant 2, I haven't reached 180 yet, so I'm going to do 180 minus my angle, or pi minus my angle in radians. So remember, you always do big minus small. So is the big angle the angle, or is the big angle 180 or 360 for the x-axis? So in quadrant number 2, the x-axis angle 180 is always going to be bigger, so that's why I do 180 minus the angle. Now in quadrant 3, I'm going past 180, so now my angle is bigger. So you can see for my reference angle, I do my angle minus 180, or my angle minus pi if I'm in radians. And then in quadrant number 4, the bigger angle is the x-axis angle of 360. So I would do 360 minus my angle, or 2 pi minus my angle. So a little tip for you guys when you look at this, when you look at reference angles, they really create a bow tie on the x-axis. So these are where all your reference angles are. Okay, so let's do a question finding reference angles. So if I have a 50-degree angle and I want to, using that reference angle of 50 degrees, I want to determine a positive angle and a negative angle in standard position. Okay, so 50 degrees, let's label our quadrants. So I'll look at my positives first, which is in the pink. So I want to know what this angle is to this point here. So the bigger angle is the 180. So I haven't gone all the way to 180. I've actually gone back from 180 50 degrees. So to figure out what my angle is, I'm going to do 180 degrees, take away my reference angle of 50. So I'm just going to adjust this here to give myself a little bit more room to write. So my positive angle is going to be 180 degrees minus 50 degrees, which is 130. So I have a 130-degree angle. That's a positive angle. Now I can do the same thing to figure out what my negative angle is. So I could go in this direction, negative angle. So this would be negative 0 to negative 90 to negative 180 plus another 50 would be negative 230 degrees. So you can count in negatives, or I have a little tip for you with this. Instead of counting in the negative direction, what I can do is once I have a positive angle, I just subtract 360 or 2 pi to get my negative angle. So I already know it's negative 230, but look, I can take my positive angle of 130 and subtract 360, and I also get negative 230. I'll just put that up there. Okay, so two different ways you can do it: counting the negative angle yourself, or using coterminal angles to kind of help you out. Okay, in this example here, I'm going to be dealing with radians. So when I'm dealing with radians, I can label my positives and negatives. Let's try my positive angle. So I'm going from 0 to pi over 2 to pi, and then I'm going past that. So I'm going pi over 6 more than pi. So my positive angle is going to be pi plus pi over 6, which is just going to be 7 pi over 6. So my positive angle is going to be 7 pi over 6. Okay, let's count our negative angle. We're going 0, negative pi over 2, and I'm going to actually go all the way to the negative pi, because I always want to go to my x-axis. So I've gone to the negative pi, and then I have to back it up pi over 6. So I can say negative pi plus pi over 6. So that would be the same as negative 5 pi over 6. So negative pi plus pi over 6. Or if you don't like to count by the negatives, you could use my tip here. Take my positive angle and subtract a 2 pi. So you can see, taking pi out, putting pi back, I'm subtracting a 2 pi, and then I can put my pi back, and you see I get the same answer. So really it's just a matter of personal preference, whichever way you want to do. And that is using the principles of coterminal angles. So let's talk about coterminal angles. If I have an angle like this and I want to sketch it in standard position and label their reference angles, and then we'll talk about coterminal angles. So let's try this. Negative 220. So negative tells me that I am going clockwise direction. Okay, so I can label my angles. So I'm at 0, negative 190 to negative 180, up to negative 270, and back to negative 360. So to go negative 220, I'm going to go past negative 180 right there. So if I want to figure out I want to sketch the angle, so I've done that, and I want to label my reference angle. So I can see I've gone past negative 180 to get to negative 220. So I just want to figure out how much past I've gone. So what I've done is I've gone 40 degrees past. Now, if you don't like to work with negative angles, my tip for you is, if it's easier to work with positive angles, you can do that as well, using again the principles of coterminal angles. So I can work with negative 220, or add on 360, I can say that this is the same as 140 degrees. So if it's 140 degrees, you know you're going to go 40 more to get to the positive x-axis, or the negative x-axis, which has an angle measurement of 180 degrees. So either way would be okay. Let's look at this one, 7 pi over 4. So again, let's label all my points here. So I'm going from 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Now, to figure this out of 4s, It might be easier if we label this here in terms of 4s. Okay, so this is the same, if I create an equivalent fraction, this is the same as 2 pi over 4. Creating an equivalent fraction, this is the same as 4 pi over 4. Creating an equivalent fraction, this is the same as 6 pi over 4. And to 2 pi, that's the same as 8 pi over 4. So that might be easier for you to visualize. 7 pi over 4 is going to be in between 6 pi over 4 and 8 pi over 4. So that helps me when I'm going and sketching it. So if I want to know what my reference angle is, I haven't made it to 2 pi. So to figure out what my reference angle is, my bigger angle is 2 pi. I can do 2 pi subtract my angle. So 2 pi subtract my angle of 7 pi over 4. Let me try that again. My pen is shifting on me here. Okay, so I can do 2 pi and subtract 7 pi over 4. So big minus small. So to do that in the calculator, I would take pi out and put pi back. So 2 pi minus 7 pi over 4, 2 minus 7 over 4 is a quarter, and then I just put back pi, so that means that my reference angle would be pi over 4. Okay, so we have been talking about coterminal angles, so just to formalize this, coterminal angles are angles with the same terminal arm. So they could be positive or negative rotations. Now, any angle actually has infinite coterminal angles because you can go around the circle multiple times. You can do this by adding multiples of 360. That's what the 360 n is, where n is an integer. That also means you could be subtracting multiples of 360 if n was an integer. Or in terms of radian, you can say your angle, you're adding on multiples of 2 pi. Again, since n is an integer, it could be a positive or a negative. So you could be adding or subtracting. Now that's where your angle is your principal angle. That's the smallest angle possible between 0 and 360. And you're adding on multiples, which is n, and n is the number of multiples. Now that's the way that we write it, and that's the way the diploma writes it. The textbook writes it a little bit differently. They write it as plus or minus multiples of n because n is a natural number, and natural numbers can only be positive. So just when you're checking your answers in the textbook, so you're aware of that and don't think you made a mistake. Let's try an example. I want to list 2 positive and 2 negative angles coterminal to the following. So 437 degrees. There are multiple answers. So I'm just showing you my answers. You could have something different. So what I'm going to do to figure out a coterminal angle is I'm going to start by adding 360. So you can see I add 360 and I get my first coterminal angle. Now I could add 360 again, or what I noticed is 437 is all the way around the circle once and a little bit more. So I actually subtracted a 360 to get another positive angle, 77 degrees. Now to come up with negative coterminal angles, I could work with 437, but I'm actually going to work with 77 because that's the smallest positive angle. So if I subtract 360, I will get into the negatives right away. So I start with 77 and I subtract 360, so negative 283 degrees is an angle, and then I can just subtract 360 again, and negative 643 is another coterminal angle. So I'm going to do the same thing for pi, but remember pi is an irrational number and I want exact values, so I'm going to always take pi out and put pi back. So to create a coterminal angle to 3 pi over 7, I'm going to add multiples of 2 pi. So 3 over 7 plus 2, put pi back, is 17 pi over 7. And then I took that answer and added another multiple of pi, and again putting pi back. So I can do the same thing starting with 3 pi over 7, and this time I will subtract multiples of 2 pi. So 3 pi over 7, take away 2 pi. Take pi out, and then put pi back. And then I can take that answer and also subtract a 2 pi, and put pi there is negative 25 pi over 7. So I just want to end with 2 more examples of coterminal angles where we're finding the number of rotations and we're finding an angle given the number of rotations. So in this example here, I want to know how many rotations has an angle starting at negative 567 degrees and ending at 1,350 degrees gone through. So I could just keep on adding multiples of 360 and figure out the answer, but I want to do this efficiently. So what I'm going to do is I know if I start at negative 567 degrees and I add on multiples of 360, eventually I'll get to 1,350. I just want to know how many rotations I've gone through. So I'm going to isolate for n. I'm going to do that by adding 567 to both sides. So I can add those numbers together and I get that 360 degree n equals to 1,917. And then I can just divide both sides by 360. And then I'll get my final answer. So the number of rotations that it's gone through. Now, depending on how the question asks you to answer this, if they want to know to the nearest whole number how many rotations or to the nearest tenth, just pay attention to how the question is worded. Now, it says how many rotations has it gone through? So to me, it has gone through 5.325 rotations, so 5 rotations and a bit, or you can say you could round it up, but I would actually leave it as 5.325 because technically if I did 5 rotations I haven't reached it, and if I did 6 rotations I also haven't reached it. So since I want to reach it exactly, I will leave it at 5.325. Okay, in this question here, I'm asking you for what the first coterminal angle to 173 degrees, negative 173 degrees, greater than 34,300. So let me just say that again. I think I tripped on my words a little. What is the first coterminal angle to negative 173 that is greater than 34,300? So I chose really big numbers so that you couldn't just keep adding on 360 until you got to the answer. But I'm going to use the same method I did in the last question. So negative 173 plus multiples of 360 give me 34,300. I'm just going to solve for n. So first thing I'll do is add 173 to both sides. So just so I'm keeping the number in my calculator as I go, I just add it and I get 360 degree n equals 34,473. Okay, then I'm going to divide both sides by 360 degrees. There we go. And so dividing that, I'm going to get 95.75. Now I want to know the first coterminal angle greater than that. So I don't need to know exactly at that. So what I'm going to do is I am going to round this up and say that it is 96 full rotations. And I want to know what my angle is. So starting at negative 173, if I went through 96 full rotations, I want to know the first angle that would be greater than this one here. Okay, and it has to be coterminal. So that's why I'm adding on, I'm rounding it to 96 because I'm adding on multiples, like full multiples, not part multiples of 360 degrees. So you see what I did? 173 degrees negative, so negative 173 plus 360 degrees times 96 rotations. So the first angle greater than that, 34,387. Okay, so to summarize the lesson, to change from radians to degrees, radians, pi goes on top. To change from radians to degrees, degrees will be on top, 180 degrees. So whatever you're converting to 2 radians, pi goes on top. 2 degrees, pi goes on, or sorry, 180 degrees goes on top. Positive angles go counterclockwise, negative angles go clockwise. Remember that your reference angles are acute angles made between the terminal arm and the x-axis, positive and negative. And to find coterminal angles, all you have to do is add on multiples of 360 or multiples of 2 pi. So back to the joke about, or to the explanation that circumference in a circle is 2 pi. This circle says, I'm sorry to pi, you just don't complete me, because it's in fact 2 pi that completes her.